We are all pretty familiar with the dangers of UV exposure from the sun. We regularly use broad-spectrum sunscreens to block damaging UVA and UVB radiation. However, did you know there is another type of dangerous UV radiation called UVC? But don't worry, it is completely blocked by the Earth's ozone layer and atmosphere. Thanks, atmosphere! Today we will learn how one company is using specialized light-emitting diodes to generate UVC radiation to kill bacteria, spores, and yes, even viruses. Jim Archibald, a senior engineering manager at AMS Osram, is our guest expert on today's Tech Chat, brought to you by Mouser Electronics. Thank you for joining us today.
Oh, thanks, Dale. Looking forward to it.
Me too. Jim, we can't even get past your title slide here, and I already have a question. What is UVC?
Sure. So UV stands for ultraviolet light. There are three types of ultraviolet light. There's UVA, which causes aging of your skin and wrinkling. There's UVB, which will give you a sunburn. And then there's UVC, which is mostly filtered out by the ozone layer of the atmosphere, but UVC is actually used for purification, and that's what we're focusing on here today.
Okay. So now that I know what UVC is, tell us about your topic here for today.
Sure. So the title is Smart UVC Disinfection Solutions, but I could boil it down into a catchphrase, which is lights on, germs gone. So the idea is by using ultraviolet C radiation, we're able to kill 99.9% of germs, bacteria, fungi, viruses, and it's a really cool solution. And it really saves a lot of effort and chemicals and waste products because you're just using a very natural, clean source of UV light to disinfect things. So it makes the world a safer place, and it's a pretty cool idea.
Well, awesome. I'm excited to hear more. So what's on the docket for our presentation today?
Yeah, so I had 5 things I wanted to cover. First, we'll talk a little bit about the general market considerations because there's really all kinds of aspects to that. Then we'll talk about how does UVC radiation actually work. The third thing I wanted to discuss was typical disinfection use case examples. And then fourth, there are some important safety considerations for UVC-based disinfection solutions. And then lastly, the fifth thing I wanted to cover was some portfolio options from AMS Osram of some products for this application.
All right, well, let's dive in.
Okay, so on this slide, there's kind of a lot on here, but if you go down the left side vertically, you'll see that UV disinfection applications apply to air, so you can purify the air around you. You can get rid of germs off surfaces of things, whether it's a countertop or a floor or whatever. And then you can also purify water. So those are 3 very huge categories. And then if you go across horizontally, you can see that there are consumer applications in the home. You can see the vacuum cleaner and the water bottle and things like that. But then the next column over, there are industrial applications for offices and schools and all kinds of things. And then finally, there are special applications, like you can see the aircraft up there. If you could easily disinfect an aircraft after everybody got off, that would be cool. Also medical applications, doctors' offices, hospitals, things like that. So there's lots of applications for UVC disinfection.
So prior to 2020, I don't recall hearing much about disinfection of the air. So is that new, or was it just occurring and I didn't know about it?
Well, it's been around for a while, and in fact, there are UVC lamps and light bulbs made by Osram, who AMS and Osram recently combined together. So it has been around, but you're right, it's gained a lot of traction because everyone knows about pandemics and everyone has learned a lot about virology and pathogens spread through the air and on surfaces. So all of a sudden, UVC disinfection is a very huge application with a lot of growth expected.
That makes sense. Now, simply just based upon these images, I would hazard a guess that the solutions can be pretty radically different depending across the segments. Is that correct?
Yeah, they vary in the power level and the scope. It scales from very small to very large depending on the application, but it's the same core UV illumination technology that you want in all those applications. But yes, it definitely scales in size and scope.
Are there other factors that define the market segments and or the disinfection process?
Yeah, so on this slide, I'm trying to show that there are static applications. So a static application is like a room. And so for that, let's say it's a doctor's office, when people leave that room, you can run the illumination at a lower power for a longer exposure time. So those are static applications, but then there are dynamic targets or dynamic applications. And for those, you typically want higher power, but for a shorter duration. So there are all these aspects, and what this all boils down to is you want to have a safe environment because UV exposure actually is bad for your eyes and can damage your skin as well. So you want to target the UV exposure, just the right amount of power and the right duration to kill what you want to kill and not damage or expose people.
So we don't usually worry too much about UVC naturally occurring because of the ozone layer filtering it out. But now with this artificial generation, we got to take that into account.
Absolutely. Yeah.
So as you mentioned, we've all been thinking more about disinfection and pathogens these past 2 years. Has COVID caused a major change in the UVC disinfection market, or was it already growing substantially even before that?
Yeah, so it's been growing at 26% year over year, but we see it starting to accelerate, actually more than that. And it is because of the pandemic. People are just much more aware of it and people worry about germs. And there are also some other things. There is an international movement to remove mercury from lighting fixtures from lamps, and mercury is used in UVC lamps now. So that's actually driving more to the LED based UV, which is what we're talking about here today as well.
So one of the things that we've been tracking here at All About Circuits and really everyone in the electronics industry is the supply chain issues. Are you seeing any supply chain issues that are going to limit the growth of UVC market in the near term, preventing you from meeting this expansive demand?
Yeah, so the supply chain for the semiconductor industry has been an issue and it's impacted the automotive and other industries. So we are very aggressive about expanding our capacity and fixing liabilities or chinks in the supply chain. So AMS Osram, we manufacture our own devices. We're not really hostage to a lot of the other constraints in the semiconductor industry because we control our own destiny, our own factories, our own tests. So we are actively building to mitigate any supply chain issues for us. But right now, in the pinch of things, the semiconductor industry is actually behind on that. And so we're, like a lot of other companies, working to solve that issue.
Yeah, excellent.
So, how does UVC radiation based disinfection work? Here you'll see a DNA cell. So, the DNA is composed of those two polynucleotide chains or strands that coil around each other. What happens with the UVC radiation, if you can see the little purple sun that's attacking the cell, it weakens one of the bonds within the DNA. And so what that does is it makes that cell weaken so that DNA cannot replicate. And so basically you're making it so the virus or the bacteria can't reproduce. So that's the basic principle behind it, is you're just weakening the cell and it can't reproduce. So one other thing that I'd like to mention is there are a few factors that are involved in successfully killing a pathogen, and that is the intensity, the power, which is measured in watts, radiation flux, and also the length of time. So different pathogens, if you look down that list, it's kind of small on the lower right, but you'll see Giardia and salmonella and hepatitis and polio. You see that each of them, depending on how much you want to kill of it, if 90% eradication is sufficient, that would just be purifying. If that's good enough, you can see that's the first column of how many millijoules per centimeter squared. So it's basically a power over an area and the time duration. And depending if you want to knock out 90% of it or 99% or 99.99%, that all depends on the power level and the duration. And it varies, as you can see, for the different pathogens.
And is it this type of radiation damage to the DNA and RNA? Is that why it's also dangerous to us as humans to be exposed to it?
Exactly. Yeah. It can damage your eyes, it can damage your skin. And this is the UV that we don't really get exposed to. Most of the UV that comes through is A or B, and C is really something we're not used to. And it's a good thing that it's filtered out.
Yeah, sounds like it. Now, that table of pathogens doesn't appear to list any of the coronaviruses. So, can I safely assume you're going to address the elephant in the room before we get done with your slide deck today?
Absolutely. Yep.
So,
Yep.
one of the notes on this slide mentions that disinfection is a function of the radiation wavelength. How much does the effectiveness vary with wavelength?
Yeah, it actually varies a lot. There's kind of a, I don't know if this is the right term, kind of a sweet spot that affects many, many different pathogens. And that sweet spot is 265 nanometers. Now, it turns out that if you're building an LED, UV LED, the way that we build them with aluminum gallium nitride crystals, the amount of emission at 265 nanometers is actually very small. So to offer a compromise between what's the most effective frequency or wavelength where the pathogens die and what can a UV LED actually emit, we've made our devices focus on 275 nanometers. So we're still getting really good, effective disinfection, but also we're getting some good yield out of our devices.
Yeah, you're still there up at near the peak there. It's still pretty flat. So that makes sense that you are limited by your material of how much you can tune that wavelength. So,
Yeah, crazy physics.
yeah, I was actually thankful that you answered what was going to be a semiconductor question for me is like what material you're using.
Yeah, yep.
So here you're mentioning disinfection rates. How are those types of tests completed?
Yeah, so this is a sample used on our Oslon UV3636 device. And in this case, we're testing on this Bacillus subtilis spore, which is a bacteria that's found in soil and in vegetation. And so what we're trying to show here is that the more exposure, if you look at that upper right chart, the UVC dosage there in millijoules per area, the more the dosage is, the more you're eliminating or reducing the number of spores. So it goes, from 90% and all the way down to 99.99% reduction. And you can see with the pictures, the 5 pictures there towards the bottom, before irradiation, you see a lot of those Bacillus subtilis spores growing in the Petri dish. And then the more exposure to the UVC light, the more it's eliminated till you can see it's 99.9% reduced. And this is just one of many pathogens, but kind of in the small print at the bottom, you can see we've also listed E. coli. And for that one, we're saying if you want just 90% reduction, that would take 5 seconds at 275 nanometers with this particular device. 8 seconds of irradiation will get rid of 99% of the E. coli, and 10 seconds and you're 99.9% gone.
Yeah, those are pretty amazing numbers for such short times. And E. coli is a pretty nasty pathogen.
Absolutely.
I do have to say there's something both cool and a little creepy about that last image with the mass disinfection of the spores to write out the OSRAM UVC.
Yeah, I know. It's just one of those things. So,
It's a great marketing image, though.
yeah.
Jim, I think we've all waited and waited. What about COVID-19?
Yeah. So, can UVC radiation also kill the COVID-19 virus? The answer is yes. That's the SARS-CoV-2 virus. And we're just summarizing some of the research found here. It also gets rid of some of the other related SARS viruses like SARS-CoV-1 and MERS as well. So this falls right in line with many, many other viruses and bacteria that have been tested. And so UVC radiation absolutely will take out the COVID-19 virus.
And I guess we'd expect that since you're breaking up the DNA or the RNA, that it's not going to really matter what you're hitting with it.
Exactly. Yep. Okay, so I wanted to talk about some typical disinfection use case examples. So the first one here, we're talking about a washing machine. If you look at the very left side, now our company is based in the EU. We're based in Austria and Germany, and they have a rating for efficiency for appliances. So the green A++ at the top is the best. It's the most efficient. It's the most green. And so if you could lower the temperature of the water, you're using less energy. If you can use less water, that's a good thing. And the goal here is to become A+++. So you can look at that table right next to the colorful chart on the left. It just talks about some efficiency classes for washing machines. And so you can see energy consumption, the A+++ is 150 kilowatt hours compared to a 12-year-old machine, which is 250 kilowatt hours. And you go right down the list of energy costs, water consumption, total costs. If you can implement a UVC LED placed between the door and the drum to do the disinfection, you can make a much more efficient washing machine for a very small increase in price. So we look at it as less than 1% of the machine cost, and then you can have this disinfection system without, again, having to use very hot water or run the machine longer and all that.
So tell me if I'm understanding this correctly. This UVC disinfection system is keeping the washing machine itself disinfected. It's not really disinfecting the clothes in the washer.
No, it's doing both, actually. It is on when the machine is on as well. So it is disinfecting the clothes while it's running. And it's keeping the machine germ-free.
Oh, okay. What are some other use case examples?
Yeah, so here on the left, we're showing an office troffer fixture. This is just a lighting fixture. So you could make it so that your lighting fixture disinfects the room. Imagine if you had a doctor's office or a cafeteria or something, or a restroom. And as long as there's nobody in that room, and we can talk about how to sense that in a minute, but you can do the disinfection automatically using the lighting system that's already in the room. Another example, I'm going to move over in the next one in the center column there. This is an air conditioner with built-in disinfection. So as the air is processed through the heat exchanger and the filter and flows through the system, you have some UV lamps in there. So as that air goes by, it's also disinfected as it goes along. So that's another pretty cool way to get really, really pure air. And then the third one over on the far right is a water example. So this is a water tap. So you're able to disinfect that water, kill the pathogens in the water as it flows through.
So looking at these three examples here, so the first one on the left, you've got a static solution, but you're further away. Do you have to increase the power because the source is removed from what you're trying to purify?
Yeah, absolutely. Not only is it further away, but also to cover the floor space of that room. You can see there are numerous UV lamps in that example. So yeah, you need to cover that distance. So that's going to be higher wattage, and also you need more of them.
And then for the other two, those are dynamic, so you kind of have to increase the power. In this case, it's a smaller volume that you're covering, but because you got stuff going past it, you got to get it done quickly.
That's true. These would be fairly intensive systems as well because, like you said, it's dynamic and you only have a short time to blast those germs.
I actually saw my first faucet with UV disinfection in a parade of homes a while back. Now I know what was going on inside of it.
Mm-hmm. Yeah.
So thanks for educating me.
Sure. Yeah, so on this slide, you can see it's really the same examples that I just reviewed with the office troffer lighting, the air conditioner, and the tap water. We're just trying to go through some typical parameters to show what the requirements are of the system in terms of power and how many LEDs per system you'd need and the total amount of milliwatts and things like that. So this is really to give you an example. If you're working on one of these applications, you're going to need some kind of guideline to know, well, how many LEDs am I going to need and what's the typical power level and all that. So this is just kind of a working guide to help compare the different applications.
So at the bottom here, you have some optional components. Can you explain a little bit more detail what those mean?
So at the bottom, you'll see there are optional components. So in addition to the UV illuminator, you really want to make sure that you're providing enough power and for enough time, but not overdoing it. In other words, you don't want to waste energy, and also in other systems, you really don't want to overexpose in case there are people, if it's a consumer application or something, you don't want to overdo it. You want to do it just the right amount. So AMS Osram has a UV sensor. For now, it's a test chip. It's called the AS7331. And that device will actually sense not only UVC, but also UVA and UVB. And so that device will come out in late 2022. But that will tell you if you are illuminating the target enough. So that's very helpful to know. Another optional component on the two examples on the left, the troffer and the air conditioner, is a one-dimensional time of flight. That is a presence detector or a 3D stereo vision system. That's kind of like what you might unlock your phone with. It looks at your face and it makes a map of your face and recognizes you if you're in the database. Well, you could do the same thing with a 3D stereo vision system. We make at AMS Osram the components that go into those kind of systems. And what that would do is tell you, hey, there's a table in the way, or hey, you got a bunch of chairs here. And so you could, adjust your system accordingly and then direct time of flight. And then the last thing is there might be other ways you want to warn people. So this safety projection per luminaire, maybe you want to illuminate on the floor a little warning symbol or something like that. So AMS Osram, we make these optical illuminator devices and these multi-lens arrays that will put a symbol on the floor, an arrow or something like that to warn you that the UVC system is operating. Important considerations for UVC-based disinfection solutions. So, Dale, as we've discussed, these are kind of dangerous systems because UVC is not something that humans are exposed to, and it does damage cells. It'll damage your skin cells. It'll damage your eyes. So this is just a short list of some of the typical safety warnings and notices that we're seeing on different UVC systems. And it's important that this kind of warning is part of it. And I'll just read a couple of them. So like in the lower right, a door switch may be used that switches off the product if any door is opened. So for example, if you put your phone, you might put it in a little box that's going to irradiate the phone with UVC. But if you open it up, you don't want that UVC going in your eyes. So things like that to warn people, or automatically turn it off. Another key one would be a presence detection, so that if someone walks in, the doctor's office while it's irradiating everything, it automatically senses someone's there and it turns off. So this is very important, and it's an amazing technology, but it's not without risks. So you have to keep this safety aspect in mind if you're going to use UVC radiation.
So one of your earlier images showed a UVC system installed in, looked like a classroom or a lunchroom with a window. So the installation, I'm guessing, would have to account for windows where either a person can walk by outside, so maybe blinds have to come down or something like that?
Yeah, it could be something like blinds come down, or it senses that somebody walked by. The system could automatically turn off if someone goes by. And also there are ways to sort of aim the system so you're hitting the target you want and not spraying it where you don't want. But those are all part of the design considerations.
So, Jim, you mentioned here locking devices, door switches, warning signs. What you're really saying is there needs to be an integrated system planning process when considering this type of installation.
Yeah, absolutely. So I wanted to talk a little bit about some of the portfolio options for realizing a UVC disinfection system beyond just the illuminator, which is the obvious part. But there are these other things, as you mentioned, in the system. So in this image here, if we go around the edge, there's the light source at the upper left, obviously. But then the presence detection, as I mentioned, you want to know if there are people or foreign objects or a pet in the area so you can turn off the system or do whatever action you want. You may want a tamper or mechanical misalignment detection so that you can tell if the module got moved or is aiming the wrong way. I mentioned before the 3D sensing, so you can detect what's in the room and maybe adjust for that, or turn on part of the system for a longer period of time to make sure everything gets exposed. Warning projections, as I mentioned, you could project an image on the floor or something, warning UV system in use. Biometric access, again, if you wanted to make it so it looked at a fingerprint or looked at the face ID of the person to turn on the system. Contaminant measurement, there are ways to do that as well that I'm not discussing today, but it's something else that we could talk about. And then there's the UVC dose monitoring, where you really want to know how long or how much of the radiation is getting where you want, and timing how long it's been exposed to make sure you're really getting rid of the stuff you want to get rid of.
Well, that seems critical long term. When you think about an installation in a facility where it might be there for years or a decade, and over time, LEDs are going to start wearing out. So you're going to have to monitor what that energy is.
Yeah, absolutely. So LEDs, they do dissipate over time, and UV LEDs are no different. They are going to wear out and have some degradation. So that's another key part of having the UV sensor monitoring. Well, how much is really being emitted from that UV illuminator?
Yeah, and with an integrated system like that, like you kind of noted, you could increase the time a little bit next year when it just takes a little bit more time, a few more seconds or something to extend the life of the system, with still giving you the confidence that it's doing what it's supposed to be doing.
Mm-hmm. Yeah, exactly. It's a feedback system. That's what works best for this kind of approach.
There's a lot going on here. It's almost a little overwhelming. So, does AMS Osram provide additional resources and assistance for companies that are interested in pursuing this further?
Yeah. So AMS Osram, these are solutions that we have in our portfolio. Two of them are highlighted in blue. The Oslan UV 3636, that comes in three different power levels. So that is the UV illuminator that can really be used in all the systems that we've talked about. We have other products here. Some of them are in the future. But the other one that I wanted to point out was the TMF 8801. That's a one-dimensional time of flight that will sense presence up to 2.5 meters. We also have another time of flight sensor that will measure up to 5 meters and actually will sense multiple objects. But these two products are very well supported devices, and these are available at Mauser.com as well.
Excellent. So, we're getting closer to the end of our tech chat today. Can you summarize everything for us?
Yeah, absolutely. So, as I mentioned at the beginning, we have kind of this catchphrase, which is lights on, germs gone. And so, instead of having to use these toxic chemicals and have people working in harsh environments and all that, you can use UVC radiation to clean surfaces, clean air, clean water. But there are the cautions to make sure that it's safe and that it's a system approach. It's not just turning on the lights. It's lights on, germs gone, but there's more to it. The other thing is AMS Osram is an innovation leader. So we're developing new products all the time for the entire system. And we have a great track record on the sensing side as well as on the illuminating side. And then the this broad portfolio. I hinted at some of it with the 3D sensing and some of the other technologies that we have. We think that this is a very important market, that it's important to the health of people. It's at the forefront of everyone's mind these days, and we think it's important and really something that helps mankind, and we're trying to provide all the tools to make these systems realizable.
Yeah, that's excellent, Jim. It's something that we wish we weren't thinking so much about, but certainly, as you noted, it is very important.
Yeah, absolutely. Yep. Sign of the times, I guess.
Exactly.
Okay, so we're very excited that we have the key products that I've mentioned for these UVC systems available on Mouser. So there's a link here to the Mouser microsite for the Oslon UV3636 LED emitter. If you go there, you'll see that it comes in 3 power levels: 4.7 milliwatts, 13 milliwatts, and 42 milliwatts. So that's the go-to place to get more information about the illuminator itself. And then the other part of the system that we talked about was time of flight presence detection. And the TMF 8801 also has a microsite on Mouser. And I would suggest people go there to learn more about that part and how it can detect presence. It can detect not only if someone's there or not, but actually it'll accurately tell you how far away the person is. So these two products, the Oslon UV illuminator and the time of flight sensor, are very important for these kind of systems, and we're really happy to be working with Mouser to promote these.
So now as we wrap up this edition of Tech Chat brought to you by Mouser Electronics, we want to thank AMS OSRAM and especially their Senior Engineering Manager, Jim Archibald, for taking his time to educate us about smart UVC disinfection systems today. So thank you, Jim.
Thank you, Dale.
Appreciate your time, and everybody else, stay tuned for our next edition of Tech Chat.